All right, we are in the home stretch, finishing up this semester and more importantly, term 2, and we're going to finish doing volume. All right. Due to lack of time, we would sometimes also cover surface area, but we are strictly going to just do volume these next couple days. Before we jump into the formulas, I want to talk about the different types of solids we're going to be looking at. Today, we're going to talk about prisms and cylinders. All right, so I want to talk about those parts, and then we'll jump ahead and look at how to find volume of those solids. Tomorrow, we're going to cover the rest. We're going to cover pyramids, cones, and spheres. And then again, we'll talk about those parts and also find volume. So let's get started. A prism, all right? Prisms have two parallel bases. Two parallel bases. That's how you know it's a prism. All right, so this first one, this shape here, specifically, this one is a rectangular prism. All right, notice it's AR at the end, not ER. So you name a prism based on the shape of its base. Now, typically we like the base to be on the bottom and then the other base to be on top. That's visually how we like things, but they could be the two sides, all right, could be your bases, and also the front and the back could be the base for a rectangular prism. You've got lots of options. So what I'm going to do, I'm actually going to use my pencil. I'm going to shade in the bottom rectangle, and then, of course, the top would be its parallel base. All right, so this would be called the base. And the top also is a base. Both of them are. Now, I'm intentionally using a capital B when I write the word base. All right. The segment that connects those two bases is your height. All right. And again, I'm intentionally using a capital H, because what you're going to be doing to find volume is you're going to be finding the area of the base, and then you're going to be multiplying it times the height of the solid. All right, so we use big B and big H to kind of represent the big parts. But within each of those formulas, you might be using little b's and little h's, as I'll show you a little later. All right, so besides our two parallel bases here, which are rectangles, hence the name, all right, the height connects those. So any of these segments all the way around, all right, even this dotted line back here. Of course, the dotted ones refer that we can't actually see them if we were looking at this solid in person. All right. The sides are also known as faces. All right, so this would be a face. Actually, every surface is a face. All right. The segment here, kind of the creases, are known as edges. And then the corner, which would actually be a point, that's a vertex. All right, just so you're aware of the different names that go along with all these solids. So the next prism, this picture right here, all right, it also has two parallel bases, but the ones that are parallel are this one here and this one here. If you were to shade in one of the other ones, you wouldn't be able to find a parallel base to that one. All right, so hence the name of this, because the shape of these bases are triangles, this is a triangular prism. All right, again, so this is our base. That's our base with capital B's, and then the segments that connect is our big H, our height of the solid. And then you've got other segments we could use as our heights as well. All right. Again, this crease right here would be an edge to our solid. All right, and then this is pointing right here to a face. All right, but these going around would also be faces as well. Now notice, so the bases in this shape are triangles, but the shape of the other sides are all rectangles, all right? So the sides going around also have a different name. They're called lateral faces. And these are always rectangles. And this is true with prisms no matter what the shape of the base. I could have a trapezoid base, and it would be a trapezoidal prism. All right, so the bases are trapezoids, but then the lateral faces going around are always going to be rectangles. Okay, so those are just two examples of prisms. Again, the name is based on the shape of the base. So let's say it's a pentagon base. It would be a pentagonal prism. All right, hexagon would be a hexagonal prism, and so forth. You can have a square prism, little note over here. All right, a square prism has actually a special name. Those are our cubes. All right. All right, cylinders, let's talk about them because we're going to also cover volume of cylinders today. A cylinder is like a prism because it also has two parallel bases, but specifically they are circles, two parallel circle bases. All right, so again, shade these in. All right, these are our capital B's, our bases. All right, I would assume that these arrows are pointing to those as well in this picture, but we could also call those faces. All right, so let me change that. Sorry, make you erase. All right, because each side of our shape is a face. Now, this part that wraps around, again, is called a lateral surface. And if we were to unroll it, right, if I sliced it down here, and of course this distance that connects them is your height with capital H. But if I sliced, and think of a can of soup, we sliced that label off and then unrolled it, all right, it's actually going to be the shape of a rectangle. Kind of neat. Okay, so the same kind of holds true as it does with the prisms. The bases can be different shapes, but those lateral surfaces, lateral faces are going to be always rectangles. Okay. All right, so now I'm going to jump ahead. You've got the notes printed out. Find the paper that actually starts with notes on volume. All right, so we've got the rectangular prism. Notice the volume formula is the same if we write it this way. Volume is always capital B, which stands for area of the base, times capital H, which stands for the height of the solid. So area of the base times the height of the solid. So what changes is really that capital B, because if it's a rectangular prism, then the formula that we use to find the area of a rectangle is length times width. Then we multiply that times the height of the solid. Okay, so in this picture, again, I'm going to shade in. So here are my two bases. I'll use the top and the bottom. All right, so it's a rectangle. So one side's the length, one side's the width. That's how you find the area of a rectangle. And then, of course, these segments connecting my two bases, that's the height of the solid, the H. So this is probably a very familiar formula to you. A lot of times people say, how do you find volume? And people automatically go, oh, length times width times height. Well, that's true if we're doing a rectangular prism. All right, notice here for a triangular prism, the general formula is the same. All right, capital B times capital H, which stands for area of base times the height. So underneath the B, we're going to write the area of the triangle, which is 1/2 base times height. Notice we're using little variables. All right, this really is important when you're writing these formulas because a little h in this case is very different than a capital H. So when I look at this, all right, I know it's a triangular prism. Here are my triangles. Now, they're not top and bottom. They're kind of front and back, and that's okay. So what you would need to know about this triangle to find the area of it is you would need to know the base, the little b, and then you would need to know the height, which remember is like an altitude going from one vertex down to a right angle. That would be your little h. So you would need to know that of one of the two triangles. They're going to be congruent as well. I have not said that, but your bases not only are parallel, but they're congruent. What connects those two triangles is the height of your solid. So let's look at two examples here. All right, so in the first example, we've got a rectangular prism. So when I look at this, all right, I have to identify my bases. So I will pick these two. So the volume is going to be, all right, let me just write the formula. So it's length times width for area of the rectangle times the height. So length and width, all right, 28 is my length, 12 is my width, and then the 18 would be my height. So I've got 28 times 12 and then times 18. That is all calculator work from here. So 28 times 12 times 18. Well, helps if I'm pushing the right numbers. 6,048. Now, volume, because what we're finding for the volume is the amount of space inside, and it's three-dimensional. So your units are inches cubed, always, always, always cubic inches or cubic units, whatever the units are. All right, number two, you would identify this as a triangular prism because the two bases are triangles. So what I need to know is I need to know the base of the triangle. So that's the 12. And then I need to know the height. Now it's not given on the front triangle, but it is back here. So that 10 is my little h. Now there's a bunch of different numbers given on this, but the one I need, okay, is the length of the segment that connects those two, which would be the 21. So this is my capital H. So I don't need the 13 and I don't need the 14, and that might happen in some pictures. They're going to give you more information than you need. All right, so to find the volume, I'm going to do 1/2 base times height for the triangle and then times the height of the solid. So we've got 1/2 times 12 times 10 times the 21. All right, so 1/2 of 12 is 6. 6 times 10, that's 60. So I'm really doing 60 times 21, which is going to be 1,260. This time we've got centimeters cubed. All right, so that's volume of a rectangular and a triangular prism. Let's look at a cylinder. Again, very similar, but the bases are circles. Right? The general formula, again, is still capital B times capital H. This time, my paper's just a little blurry. All right, the area of a base, because it's a circle base, is pi r squared. Right, again. And then times the height of the solid, the capital H. All right, so when you have a cylinder, you're going to need to know r, the radius, or at least the diameter, and then you would cut it in half. And then, of course, connecting those two is the capital H. Now, I am going to just quickly shade in those two circle bases. All right, so when I look at my cylinder, I see I've got my radius. That's 2. And then the 8 is the height, so that's my capital H. So I'm ready to go. So the volume of this is going to be pi r squared times the height. So I would fill in, make this times 2 squared, and then times the 8. All right, and really, as long as I see that all multiplied in, right, that 2 squared is going to be 4. 4 times 8 is 32, so 32 pi. And then make sure you use your pi key, not 3.14. And I get 100 point, I'll go out 2 places, 5.3. We're using meters cubed. All right, so that's what you're doing today. You're finding volume of prisms and cylinders. If you need any help, come see me.